She's a Mona Lisa. Everyone's lining up to see her. She's a Mona Lisa.
Example 1. It is given that the first four terms of geometric progressions are 3, -6, 12, and x. Find x. First, use the formula r equals to term 2 over term 1 and a equals to the first term, and you will get a equals to 3 and r equals to -2. Then, substitute a and r into the formula Tn equals to ar power of n minus 1, where n represents the term number, and you will get x equals to -24.
She lives a double life.
Using the formula r equals to term 2 over term 1 only. As we know, all the numbers in this sequence will increase with the same value, meaning all the number will have the same value of r. So, substitute term 2 and term 3 to get r. Now, substitute x in the formula with r as -2, and you will get x equals to -24. Example 2. It is given that 3, 6, x, y, and z are 5 consecutive terms of geometric progression. Find the value of z. From the question, we know that z is the fifth term, so n is 5. Now, like the previous example, find the value of a and r and substitute in the formula. Your answer will be z equals to 48.
Get my cash back. You be looking fine, so no wonder they can't match that Louis V scarf or I'm chilling with a dad. Whoa, slow it down like that.
Hello, I'm Carl Goss. I'm now discover the arithmetic and geometric progression. I'm going to show you how to solve question involving range. Here is the example. Given a geometric progression of 3, 6, 9, find the first term of the sequence that is over 9,000. First, use the information given. As we know from the question that a is the first term is 3 and r, the common ratio 6 divided by 3 will get 2, and the n term must be more than 9,000. And the formula of n term is ar power of n minus 1. Next, we will use the formula and substitute the value. Put the value of a and r into the formula and we'll get 2 power of n minus 1 more than 3,000. Now use log base 10. We'll put log base 10 on the both sides so it can be balanced. We use log base 10 because it can be calculated easier, as we can use the calculator to get the rational number. The next step is we'll put the log into the one side only. So we will transfer the log 2 to another side, and we will get n minus 1 more than log 3000 over log 2. Now you can solve the question. N minus 4 more than 11.55, we will transfer 1 to the other side and we get n more than 12.55. But we will not write the answer as 12.55 because the question asks for what term and the term must be in a rational number, so we get n equal to 13. Progression is easy actually, that's why I invented it. Now you can go study the question.
It is given that the first term and the common ratio of a geometric progression are 64 and 1/2 respectively. Find the smallest value of n so that the n term is less than 1/40. Alright, so from the question, it is given that the first term is 64, the ratio is 1/2, and the n term is less than 1/40. We have also learned that in geometric progression involving finding the n term, it is given the formula Tn equals to ar power of n minus 1. So what we have to do first is to substitute this formula into here. When doing this question, some of you might get stuck here because normally we would try to put them in the same base. But in this case, even if we try using the calculator, we cannot find the same base for both of these values. But there is one thing we can do, which is by adding log base 10. So it is getting much more simple here, but pay attention on this 1/2 right here. We know that 1/2 is a value which is less than 0, which means it is a negative number. Therefore, when we bring it to the other side, the sign of inequality must be inverted. continue solving and we will get n is more than 12.32. But since the question wants us to find the number of term, and of course there is no such thing as term 12.32. Therefore, the final answer is n equals to 13.